everybody. Today in this lecture I shall cover different patents granted in the field of cryptography. First of all, I shall cover basic cryptographic patents and then prominent cryptographic patents, which will be followed by few other important patents. Focus will be on a subset of these patents with primary emphasis on prominent patents of industrial interest involving fundamental techniques, specific algorithms and protocols in the area of data security. Now, let us discuss what is patent. A patent is a set of exclusive rights granted by a sovereign state to an inventor or assignee for a limited period of time in exchange for detailed public disclosure of an invention. An invention is a solution to a specific technological problem and is a product or a process. Rather, a patent provides the right to exclude others from making, using, selling, offering for sale or importing the patented invention for the term of the patent, which is usually 20 years from the filing date. In a patent, the claim in technical terms is the extent of the protection conferred by a patent or the protection sought in a patent application. The claims are of the utmost importance both during prosecution and litigation. A vast number of cryptographic patents have been issued of varying significance and use. First of all, let us see basic cryptographic patents. Table shows the list of 5 basic cryptographic patents which are fundamental to current cryptographic practice. These patents have been listed in chronological order. The patent of Ahersem et al. Covers the algorithm which later became well known DES. This patent was filed on February 24, 1975. This patent was assigned to the IBM, International Business Machines Corporation. Its background section comments briefly on 1974 product cipher patent of Fistel and Smith. It notes that while the Fistel patent discloses a product cipher which combines key dependent linear and nonlinear transformations, it fails to disclose specific details including use of key bits regarding the non-linear transformation within S boxes and regarding a particular permutation. This patent contains 10 claims. The first public key patent issued on April 29, 1980 was the Hellman-Daffy-Merkle patent. Filed on September 6, 1977, it was assigned to Stanford University, California. It is generally referred to as the Daffy-Hellman patent as it covers Daffy-Hellman key agreement. There are two major objects of the patent. The first is a method for communicating securely over an insecure channel without a priori shared key. The second is a method allowing authentication of an identity over insecure channels, and this can be done using authentic long term Daffy-Hellman public keys secured in a public directory with derivation and use of the resulting Daffy-Hellman secret keys providing the authentication. The patent contains 8 claims. The Hellman-Merkle patent was filed on October 6, 1977 and assigned to the Board of Trustee of Leland Stanford Junior University, Stanford, California. It covers public key crypto systems based on the subset sum problem, in addition to various claims on public key encryption and public key signatures. The objects of the invention are to allow private conversations over channels subject to interception by eavesdroppers, to allow authentication of a receiver's identity, and to allow data origin authentication without the threat of dispute. There are 17 claims, with claim 1 to 6 broadly applying to public key and claim 7 to 17 more narrowly focused on knapsack systems. Merkle's 1982 patent covers tree authentication. It was filed on September 5, 1979 and was also assigned to the Board of Trustee of the Leland Stanford Junior University, Stanford, California. The main motivation cited was to eliminate the large storage requirement inherent in the prior one-time signature schemes. The main idea are to use a binary tree and a one-way hash function to allow authentication of leaf values yi associated with each user I. This patent contains a single figure and just over 2 pages of text, including 4 claims. The Rivest-Shamir-Edelman patent was filed on December 14, 1977 and assigned to the Massachusetts Institute of Technology. It covers the RSA public key encryption and digital signature method. Also mentioned are generalization, including use of a modulus n, which is a product of 3 or more primes, and using an encryption public key to encrypt a message m. This patent has the distinction of a claim section with 40 claims, which is longer than the remainder of the patent. So, these were basic cryptographic patents. Now, let us move on to prominent cryptographic patents. 10 prominent patents will be discussed now, which are as shown in table. The Okamoto patent covers the original e-sign signature scheme. The patent was filed on March 11, 1985 and assigned to the Nippon Telegraph and Telephone Corporation, Tokyo, with priority data listed as March 19, 1984. The objective is to provide an e-signature scheme faster than RSA. The patent contains 25 claims. The Shamir-Fiat patent covers Fiat-Shamir identification and signatures. It was filed on July 9, 1986 and was assigned to Yeda Research and Development Company, Israel. For identification, the inventors suggest a typical number of rounds and parameter selections. A range of parameters k is tabulated for the corresponding signature scheme, showing trade-off between key storage, signature size and real-time operations required. There are 42 claims for this patent. The Mathias patent is one of the several in the area of control vector for key management, which allows a sending node to constrain the use of keys at a receiving node. It was filed on May 29, 1987 and assigned to the IBM Corporation. Control vectors are used to reduce the probability of key misuse. Two journal methods are used. In the first method, the key and a control value are authenticated before use through verification of a special authentication code, the key for which is part of the data being authenticated. In the second method, the key and control values are cryptographically bound at the time of key generation, such that recovery of the key requires specification of the correct control vector. The patent contains 22 claims. The Shimizu Miyaguchi patent gives the originally proposed ideas of the Pfeil block cipher. It was filed on November 3, 1986 and assigned to the Nippon Telegraph and Telephone Corporation, Tokyo, with priority data listed as November 8, 1985. Embodiments of Pfeil with various numbers of rounds are described with figures including 4 and 6 round Pfeil and discussion of key lengths including 128 bits. The patent makes 26 claims. The patent of Brechtel et al. Covers the MDC2 and MDC4 hash functions. It was filed on August 28, 1987 and assigned to the IBM Corporation. The patent notes that interchanging internal key halves, as is done at a particular stage in both algorithms, is actually required for security in MDC2, but not MDC4. However, the common design was nonetheless used to allow MDC4 to be implemented using MDC2 twice. There are 21 claims mainly on building two n-bit hash functions from n-bit block ciphers. The Schnorr patent covers Schnorr identification and signature schemes and optimization thereof involving specific pre-processing. It was filed on February 23, 1990 with no assignee listed and priority data given as February 24, 1989 at European Patent Office. There are 11 claims. Part of claim 6 covers a specific variation of the Fiat-Shamir identification method using a prime modulus P. The Guilleau-Quistquater patent addresses GQ identification and signatures. It was filed on October 9, 1991. The disclosed techniques allow for authentication of so-called accreditation information, authentication of messages and the signing of messages. The central authentication protocol involves a commitment challenge response method and is closely related to the zero knowledge based identification technique of Fiat and Shamir. The cited advantages over previous methods include smaller memory requirements and shorter overall duration due to fewer total message exchanges. The main applications cited are those involving chip cards in banking applications. There are 23 claims including specific claims involving the use of chip cards. The Massey Lie patent covers the idea block cipher, proposed as a European or international alternative to DES, offering great key bit lengths and thereby hopefully greater security. It was filed on May 16, 1991 and assigned to SCOM Technology with priority data given as May 18, 1990 from the original Swiss patent. A key concept in the cipher is the use of at least two different types of arithmetic and logical operations with emphasis on different operations in successive stages. There are 14 figures and 10 multi-part claims. The patent of Kravitz titled Digital Signature Algorithm has become widely known and adopted as the DSA. It was filed on July 26, 1991 and assigned to the United States of America as represented by the Secretary of Commerce, Washington, D.C. The background section includes a detailed discussion of EI-GAML signatures and SNOR signatures, including their advantage relative to RSA, allowing more efficient on-line signatures by using offline pre-computation. The patent makes 44 claims. Micali's patent filed on April 20, 1992 covers key escrow systems called fair crypto systems. The subject of the first is a method involving a public key crypto system for allowing third party monitoring of communication. A number of shares created from a user selected private key are given to a set of trustees. By some method of verifiable secret sharing, the trustee independently verify the authenticity of the shares and communicate this to an authority, which approves a user public key upon receiving all such trustee approvals. The patent contains 18 claims, the first 14 being restricted to public key systems. So, these were few prominent cryptographic patents. Now, we shall move over to other patents in the area of cryptography, which are shown in table. Fistel's patent was filed on June 30, 1971 and assigned to the IBM Corporation. The patent discloses a block cipher, more specifically a product cipher, noted as being under the control of subscriber keys and designed to resist cryptanalysis. It is positioned as distinct from prior art systems, none of which utilized the advantages of a digital processor and its inherent speed. The patent has 31 figures supporting 6 pages of text plus 1 page of 13 claims. The Smith-Branstad patent addresses key notarization. It was filed on September 29, 1980 with no assignee listed. A primary objective of key notarization is to prevent key substitution attacks. The patent contains 21 claims. The Hellman-Paulig patent was filed on May 1, 1978, just 4 and 1 month after the RSA patent, and was assigned to the Board of Trustee of the Leland Stanford Junior University, Stanford, California. It covers the Paulig-Hellman symmetric key exponentiation cipher. Merkle's patent filed on July 30, 1987 with no assignee listed on the issued patent teaches how to construct authentication trees which may be expanded arbitrarily without requiring a large computation when a new tree is constructed or expanded. The key idea is to associate with each node in the tree 3 vectors of public information, each of which contains sufficient public values to allow one time signature. The combined hash value h I of all 3 of these vectors serves as the hash values of the node I. The patent of Gauss covers a variation of Diffie-Hellman key agreement. It was filed on April 17, 1989 and assigned to TRW Incorporation, California. The primary application cited is an authenticated key establishment technique, completely transparent to end users for fax machines on existing telephone networks. At the time of manufacture, a unique device identifier and a signed certificate binding this to a long term Diffie-Hellman public key is embedded in each device. The patent makes 16 claims. Merkle's patent covers 2 symmetric key block ciphers named Khufu and Khafre. These were designed specifically as fast software oriented alternatives to DES, which itself was designed with hardware performance in mind. The patent was filed on December 21, 1989 and assigned to the Xerox Corporation. Khufu and Khafre have block size 64 bits and a user selectable number of rounds. Khufu has key bit length up to 512 bits and S boxes derived from the input key. It encrypts 64 bit blocks faster than Khafre. Khafre has fixed S boxes and a key of selectable size with no upper bound, though larger keys impact throughput. The majority of the patent consists of C code listings specifying the ciphers. The patent contains 27 claims. The Brickell et al. Teaches a method for fast exponentiation for the case where a fixed base is reused. This has application in systems such as LGML, SNOR and DSA signature schemes. The patent was filed on August 13, 1992, issued on March 29, 1994 and assigned to the United States of America as represented by the United States Department of Energy, Washington, D.C. The method is presented in algorithm 14.109. This patent contains 9 claims. So, friends, in this lecture we covered cryptographic patents. Firstly, we discussed basic patents which were followed by prominent patents. In last, few other important patents in the field of cryptography were discussed. Thank you.